four different types of formula. And the displayed formula, otherwise known as just the stick diagram, by using these little sticks to show the covalent bonds, and you would use to draw two of them to show a double bond, or three to draw a triple bond, and so on. And then you've got these are not in order of complexity, actually. The least complex would be empirical, and then it would be molecular, and then these two. Oh no, they are actually they are actually they go less complex as you go from left to right. That was not deliberate. So the one that we're used to is the molecular formula, just how many of each atom do you have in it, and then you got the structural formula, which just basically you go down the sort of spine of the molecule like that. The empirical formula is just showing the ratio of one type of element to the other within that compound. So because the general formula for alkenes is always 1 to 2 in terms of the hydrogens, let's just look over here to see the general formula over there, then that would mean the empirical formula for all alkenes is going to just be CH2. That's not going to be the case for alkanes. It will change because they've got that +2 bit for the general formula. But that would be the empirical formula for this case. Now, if we're going to do a structural formula for these kind of complicated compounds, which I'll talk about in a moment, then what you have to do is you have to decide, what do you think is the chain? What is the chain that we're going to consider? Is it going to be like that, or is it going to be across there? And then you're going to, when it comes to like a little group, this is called a methyl group. It's a methyl group because meth is for one carbon, and the group has got one carbon in it, so it's methyl. It's called a methyl group. And we're going to say that this is, well, it would be propene, prop for 3 carbons, and it's got a methyl group, so you could say it's methyl propene. That would be the name of this compound here, if I assume this is the case. However, methyl propene. Yes, if I'm saying that is the chain, but if I'm saying that's the chain, then it would be methyl. Yes, it would be methyl. Actually, I think it would just be methyl propene. Yeah, naming gets a bit complicated at this point. So, those are the 4 different types of formula. What I will say while I'm on the video here as well is that when you rearrange it in a different way, so if you look at this, the molecular formula is C4H8 in this case. Well, I could have, that if I knew the molecular formula is C4H8, I might have just assumed that it was just a simple butene, right? Yeah. So if I do that like that, then you're going to see that that basically just makes up C4H18, right? So it's the same. Yeah, let me just get that right. So those two substances, those two molecules have the same. Let me just double check I've done that right. 3, 4, 5, 6, 7, 8. Yeah, they have the same molecular formula, but they're not the same compound. They're not the same. They don't have the same structural formula or the same displayed formula when you look at them. So what we say is that these are isomers. Okay, so I'm just going to write that word down. So this is, in fact, I'm going to put it in a box here. So these two substances are isomers. When you learn in physics, you learn isotope. So we know isotopes are, and you learn it in chemistry as well, actually, but they're different versions, different types of the same atom, and this is different types of the same, different versions of something that has the same molecular formula. Okay, so both of these two here are isomers. Okay,